Okay, so this question asks us to draw the cyclohexane chair structures for all cis 1,3,5 trimethyl cyclohexane. So let's go ahead and we'll draw the flat structure first. All cis means all on dash or all on wedge. So let's go ahead and do all of them the same direction. What that means in terms of chair structures is that we have all of our substituents upward. So upward axial, and we'll go ahead and number the carbons 1, 2, 3, 4, 5, and 6. 1, 2, 3, 4, 5, and 6. So that means on carbons 1, 3, and 5 we have all upward, and in those positions that means all axial. And the ring flipped structure is going to have those substituents in the equatorial position. So if that's carbon 1, 2, 3, 4, 5, and 6, then I've got upward equatorial on carbon 3 and upward equatorial on carbon 5. All right, so which is more stable? Well, given that there's so much 1,3 diaxial, which is a type of steric strain, in this first example, that one's going to be much, much less stable. So this is the more stable structure with our methyl groups in equatorial positions. The next problem asks us to draw cyclohexane chair structures for cis 1-ethyl 3-isopropyl cyclohexane. So I'll just start with my chair this time. On carbon number 1, I have an ethyl group. On carbon number 3, I have an isopropyl group. So on carbon number 1, an ethyl group, and I can start with that being up or down, so I'm just going to start with it up. Okay, and then on carbon number 3, we have an isopropyl, and since it's cis, then this one would also have to be up. All right, and I'm going to ring flip this structure. And then that means that on carbon number 1, I've got an ethyl group up but equatorial. On carbon number 3, it's up equatorial. So that moves both of the large groups to the equatorial position. And so clearly we've got a lot of 1,3 diaxial steric strain. And so this is going to be the more stable conformation. And so I've got, this time, if I place the first substituent on carbon 1, if I place that in a downward position, it would have to be equatorial. Down is equatorial on that position. And carbon 3 then would be upward. So trans means one is up and the other one is down. And so in our ring flipped structure, the ethyl group, which was down equatorial, is now down axial. And the isopropyl group, which was up axial, is now up equatorial. All right, and so the question here then becomes, is it better to have an isopropyl in an axial position or an ethyl in an axial position? So here the isopropyl group is axial, and of course we know that the isopropyl group is the larger group, and in the ring flipped structure we have an ethyl group which is axial. Being that that's the smaller group, then it's best, if we have to choose, to put the smaller group in the axial position so that we can limit the amount of 1,3 diaxial strain that occurs. So that's why this structure is going to be more stable, and the previous one has more 1,3 diaxial steric strain.